You may figure out the decimal for 5% is 0.05. Some students have issues with half percent, it's 0.005. Or what we call 5 basis points, which is 5% of a percent. 0.05%, that would be 0.00005. Right. All I have to do is done. One thing you need to be careful, if the leading number is 0, do not omit the 0. 0.25 is 25%. Well, 0.25 is 0.25%. I also have a habit, whenever a number is an input, I do background at that cell dark red. Okay? That tells me, again, when this is your own template, you can do whatever the hell you want. Or if that is offensive to you, whatever the heck you want. I don't know why I have a curse word, but hey, I don't judge. Trust me, I grew up in a military boarding school, all boys. So saying heck is like, drinking water for me. When me and my classmates get together, we make Marines blush. Let me put it that way. So every once in a while, something may slip. Don't take it personally. This tells me that I have green light to enter stuff. What does that mean? Now, a lot of things we do in Excel are done using formulas. I'm gonna, cancel. Future value. And I tend to do a red background for cells that contain a formula, which means it is product of something. You have red light. Don't change it unless you really want to change it. In this case, I'm going to enter a formula. In Excel, all formulas start with the equal sign. Okay, let's remember our formula for future value. Present value times 1 plus r raised to the power t. Where is my present value? Right here. Instead of $100, it throws a B3 over there. That B3 is called a reference. It's referring to a certain place in the spreadsheet. Internally, Excel calls that B3. And it's just a tag. What that B3 means, go to that cell. That cell is actually an object, because it has a lot of properties. It has a font, it has background, it has notes on it. But one of the things it has a value. Grab that value. That's what B3 means. Okay, we grab that value. What are we going to do with that? Well, I'm going to multiply it with something. If that something is 1 plus r raised to the power t. There is r right here. So B1 means the value that currently resides in cell B1. That's it. Go there, grab it. Then we're going to raise it to the power number of periods. You're done. I mean, I know that this is going to work fine because I know something about order of operations, but sometimes you can be overly careful. Nobody ever died from using unnecessary parentheses, but a lot of people died from not using necessary parentheses. And I'll give an example of that. So 1 year from now, that's or 10 years from now, if you make only 0.25% every year, 10 years from now, you're gonna get only 102.53. Now the numbers changed. Interest rates went up. You know, about a year ago, Fed funds rate was about 0.25%. Now it's almost 5. At 5%, investing for 10 years is now going to give you 162. That's the power of compounding. Okay? If you're going to do this for 50 years, it's hashtag. You know what that hashtag means? Anyone? The cell is too narrow to show you the entire set of numbers. You can go to the right edge of the column and expand it, or sometimes if you double click on that, it finds the automatically enough bit so that it contains everything in that column. You know the answer for 500? Fine. Now, I'm going to show you something in Excel that some of you, most of you probably have never seen. All right. I want to double my money in 10 years. Okay? At what interest rate I can achieve? I'm going to invest accordingly. Because there's a general rule in finance, it's actually a theorem. In order to rightfully expect to make more money, you have to take more risk. So if I need to take more risk to double my money in 10 years, I will. Let's see. The trouble is, I can do it algebraically, that's not a problem. If I've solved this equation for R, well, let's start from here. Come on. I can solve R as, let me see. One plus R raised to the power T is, if I take logarithms of both sides, no, that's for T. If I raised everything by 1 over T, okay, it's an ugly formula, and trust me, it's at least ugly formula that you're going to see for a while. But I'm not going to ever ask you to know that formula. Why? Because instead of doing this, I'm going to do my one trick in Excel that I use in this class a lot. I call it, one trick pony. I'm going to write, let me copy this and paste it here. I'm going to say target value, and I'm going to also the difference. I'll have this different background to tell me something. Now, if present value is 500, let's, I want to double it, so my target is 1,000, right? I'm going to invest it for 10 years. I'm going to ask myself the following question. At what rate future value is going to equal the target value, $1,000? Or alternatively, at what rate the difference between the future value and the target value is 0. I know two of the inputs. I know the present value, I know number of periods. So I want to enter something in that period rate, and it's a very precise number so that difference is 0. First, I'm going to actually calculate it myself. And I'm going to do this to show the importance of order of operations. The ratio of future value to present value is 2, okay? I'm going to raise to the power 1 over number of periods minus 1. Okay, it says the answer is negative 8%. Obviously, there is something wrong. If I earn negative 80% for 10 years, I'm going to actually end up with almost no money in 10 years. That means every year my money is going to go from 5 to 1. In 10 years, I'll get nothing. So if I have negative 80%, yeah, I'll have nothing. It's not exactly nothing, but almost. Who's going to tell me what they think is wrong in that formula? I mean, I wrote it just like the formula here. Future value over PV, I know to be 2.
Since this was the exponent, then the fraction around it, so it's just doing x plus 1 instead of doing the exponent of 1 with b to the 3.
Exactly. Just like when you do algebra by hand or arithmetic by hand, there is an order to the operations when there's an expression. And that order of operations, parentheses are evaluated first, then exponentiation, then multiplication and division, then addition and subtraction.